Guys, this is not working. Okay. Hello everyone, welcome to IB Asian Friends. I'm Yofo, and today I will go over a question that I find interesting on page 32 of the maths book, Analysis and Approach HL. This is a question that you can find on the mixed practice section at the end of chapter 2 algebra. So if you flip to page 32, you will find a question, which is question 19, that I wanted to solve in this video. If you don't have the book or you don't have access to it, it's fine. I will show you the video here. You can pause the video and just read through the question. Okay, before starting the video, I have to warn you guys, if by any chance your screen goes black or gets dark, it's not your computer lagging or whatever. It's because outside there's having a really bad storm and thunder and raining, and so by any point my house may experience a power outage, so I won't have electricity in my house. So you just have to be patient and wait that the electricity come back, and we will proceed with the maths. Okay, but I hope that doesn't happen. Okay, then getting back to our question. The question is asking to find the first two terms in ascending power of x in expansion of square root 1 plus 5x over 1 plus 12x. We know that if it's square root, then it means that it's to a power of 1/2. So we can rewrite this as 1 plus 5x, everything in bracket, to a power of 1/2, divided by 1 plus 12x, bracket, to a power of 1/2. This can also be written not in a fraction, I mean like in a irrational form, which is, I will show you now, 1 plus 5x to a power of 1/2 times by 1 plus 12x to a power of negative 1/2. Okay, in order to expand this, we will have to expand them separately and then multiply them together. So we'll start with the first bracket. 1 plus 5x to a power of 1/2 equals to, so here I'm using the Maths HL, or even, Maths HL formula booklet. I think all of you guys have it. And you will find the extension of binomial theorem equation here, and you just have to apply it in this case. Nothing hard, nothing difficult, just apply the equation. So 1 to a power of 1/2, brackets 1 plus 1/2, 5x over 1, brackets, plus 1/2 over 1/2, 1/2 brackets 1, in brackets 1/2 minus 1 over 2 factorial 5x over 1, and everything squared, plus etc. We don't care about that part. Then we just have to simplify this. So 1 to a power of 1/2 is 1. Multiplying everything in the brackets doesn't make a change. Still 1 plus 1 over 2. Sorry, not 1 over 2. 5 over 2 x plus. If we expand the numerator, we'll get 1 over 4 minus 1 over 2. 2 factorial is 2, so over 2 times by everything squared here will make 25x squared plus etc. We don't care about that part. Then we just have to further simplify it again. 1 plus 5 over 2x plus, okay, so here we need to be careful, although it's not hard, times 2 both. You will get 1 over 4 minus 2 over 4, and we'll get to negative 1 over 4 over 2 times by 25x squared. If we simplify further, we'll get 1 plus 5 over 2x plus negative 1 over 8 times by 25. So we can just rewrite it as negative 25 over 8x squared. Okay, this is done for the first part. Now we can expand the second bracket, which is 1 plus 12x to a power of negative 1/2. Just rewriting it by applying the formula. 1 plus 12, negative 1/2, 12x over 1, plus negative 1/2, brackets negative 1/2, minus 1 over 2 factorial times by 12x over 1, everything squared, plus etc. We don't give a shit to that part. Then 1 to a power of negative 1/2 is just 1. Then we have to expand this, which is negative 6x plus negative times by negative gives positive 1 over 4 times minus 1 gives plus 1 over 2 factorial, which is 2. Then 12x everything squared will give 144x squared plus etc. This will give us 3 over 4 over 2. Yeah, I'm just writing a bit casually, but hope you guys can understand. By 1, so this one doesn't really make a change to anything. 1 minus 6x. 3 over 8 times by 144 will give us, it will give us positive 54x squared. So we got the expansion for both brackets, which is this thing and this thing. Okay, now we just have to multiply these two things together and to find the final expansion. So I prefer to rewrite it on our paper because it's messy, and you know, maths is just making things look prettier, so it's just better to rewrite it and solve on this paper. Okay, now we're going to expand these two brackets. 1 multiplied by everything in this bracket will give us 1 minus 6x plus 54x squared. 5 over 2x times by everything in this bracket will give us plus 5 over 2x minus 30 divided by 2, 15x squared, plus 5 over 2 times by 54 will give us 270 over 2x cubed. Yeah, that's it for 5 over 2x. Now we have to also expand for negative 25 over 8x squared, which is negative 25 over 8x squared plus 150 over 8x cubed. We can also expand further to get a coefficient of x to a power of 4, but since we're asking only for the first two powers, I mean in ascending powers of x, so it's not necessary to expand to that point. But if you want to waste your time, yeah, you can do it. Okay, everything this has to be simplified by adding or subtracting the coefficients of each x's. So you have x here, x squared here, and here, and a 1 that is alone. So you will get 1 minus 7 over 2x plus 287 over 8x squared. So this should be our answer for part A of question 19. So now if we move on question B, I mean 19b, we're asking to find the value of x for which the expansion is valid. So this seems hard, but it's not. You just have to write the brackets that you expanded before. So we used 1 plus 5x to a power of a half and 1 plus 12x to a power of negative a half. So we have these two, and we have to find the value of x for which expansion is valid. So in this case, we will have to use the equation or formula, I don't know, that I hope you guys know. So absolute value of x smaller than 1. We'll have to use this. So this is very easy to use. When you're using this, you just have to substitute the x with the b part. So normally this thing will be a plus, I don't know, or subtract b and to a power of n. So you just have to substitute your b part, which has x at the back. So in this case is 5x. Just substitute in here. Absolute value of 5x is smaller than 1. We'll have to make x alone. So just rearrange it and move the x to the other part by dividing it. So x absolute value will be smaller than 1 over 5. So this is for when x is valid in this expansion. Now we'll have this one, which is the same thing, just by substituting 12x smaller than 1. So you will get absolute value of x smaller than 1 over 12. And you will want to choose the smallest one, because if we get the smallest one, which is this one, will also be contained for this value. I don't know how to explain it directly, but let's say if x absolute value is smaller than 1 over 12, it's this range, and x absolute value of smaller than 1 over 5 is this range, when we know that x absolute value smaller than 1 over 12 also fits into the range of x absolute value smaller than 1 over 5, but 1 over 5 doesn't fit into the 1 over 12, I would say, equation. So we will have to choose the smallest one, which is this one. So this will be the answer. I know that I explained it really badly, but I hope you understand. But if you don't understand, you can always comment. You can always post a comment below, and I will try to explain better in the next video. So this is basically how you do part B. Now, moving on to part C. So part C says that by substituting x equals to 0.01 into expansion in part A, find an approximation to square root of 15 to 2 decimal places. So what is part A saying? I mean, expansion of part A. We're given that square root of 1 plus 5x over 1 plus 12x in part A. This is equivalent to the expansion that we just did before. So this one. So we can say that square root of 1 plus 5x over 1 plus 12x is equivalent to 1 minus 7 over 2x plus 287 over 8x squared. Okay, since we're given that x is equal to 0.01, then we can just simply substitute into both sides. So we'll get square root of 1 plus 5 times by 0.01 divided by 1 plus 12 times by 0.01. The same thing for the other side. Okay. So now we will have to just expand both parts and find what is square root of 15, because they want us to find an approximation to square root of 15 to 2 decimal places. So 5 times by, so we will start on the left hand side. So on the left hand side, if you do 5 times by 0.01 is equivalent as saying 1 over 20, right? Same thing for 12 times by 0.01 is equivalent to say it's 3 over 25, equal to, if you plot all this in a calculator, you will be able to get this number, 0.961. Yeah, this is calculator allowed, so you don't have to do it without a calculator, just a waste of time. So now what we're gonna have to do, we'll have to make this left hand side more prettier. So we know that 1 plus 1 over 20 is the same thing as saying 20 over 20 plus 1 over 20. Same thing for the bottom part, 25 over 25 plus 3 over 25, which is equivalent as saying 21 over 20 over 28 over 25, everything square root. And this is equal to 0.961. It's a bit messy, but I hope you understand. If you don't understand, yeah, just post a comment under and I will explain it later again. And yeah, we can also make this even more simpler by saying square root of 105 over 100 over 112 over 100 equals to 0.961. Now, since on denominator and numerator we both have 100, we can just simplify by saying square root of 105 equals over square root of 112 equal to 0.961. If we divide both numerator and denominator by 7, we will get square root of 15 over 16 equals to 0.961. Now, we can rewrite this as square root of 15 over square root of 16 equals to 0.961. Then you just have to rearrange the formula by moving square root of 16 on the other side, so multiplication. And then we'll find the answer, which I will write in my calculator and see what we get. 0.961 times by square root of 16. 3.844. And let's see what the answer says.
Wait.
Okay, the answer is 3.87. But I think this is because we didn't write out the full decimal places after the 0.961. If we were able to just write everything, then I guess we'll still get the same answer as the textbook, but it doesn't really make a difference. So yeah, we still got it right. I hope this video helped you guys to understand better binomial expansion and how to find value of x when no value of x, find approximation when x is given. If you have any questions related to maths or maybe even physics and chemistry, if it's biology, you may have to refer to my colleague. And yeah, that's it. See you in the next video.